Hey friends. So Zoom issues. We're gonna review some things for the tests that are next week that I have particular concern about, things that we either talked about early on and I figure you might have forgotten, or things we didn't have a lot of practice on. And so normally we would do this as a Kahoot and then we would talk about every question as we go through, but I just want to talk about some of the questions in this Kahoot. You are able to do this Kahoot. If you go to Number in Algebra on slide 97, there's a whole bunch of review Kahoots you can play, and you'll be able to check the answers as you go. You just play. Or if you click this, it's going to take you to Kahoot, and you should be able to see the answers just by clicking on it, right? So I want to look at a couple of these and review some of the ways that we answer these questions. I want to review in particular the idea of the model we were using to answer these questions. So remember, boundaries, upper and lower boundaries, are basically like rounding issue questions. So I measured to some level of accuracy, and so it's possible that my measurement was actually a little bit above or a little bit below what I claim the measurement is. So like in this case, this person is saying, my garden is 5 meters long to the nearest meter. So 5, right? So it's possible somebody else, right? So the other thing they could have got was a 4, or they could have got a 6, right? Those would be like the other ways this measuring could have gone. So this person then somewhere in here, right? This is the possible measurements. Halfway between 4 and 5 and halfway between 5 and 6 are where we sort of think about rounding. So if we're at 4.5 here and 5.5, we know that this right here is the possibility of, it's the window of possibilities, right? Like, so their actual garden could have been somewhere between here and here, but we know that we rounded it to the nearest meter, therefore it's 5. So the upper boundary of this is 5.5. So this is a pretty straightforward example. We're not going to do all of these questions. I wanted to look at some. We're going to come down here and look at this question right here. A piece of rope is measured as 3.2 meters to the nearest centimeter. What is the upper bound? So again, 3.2 meters is the center. 3.2. And then we're measuring it to the nearest centimeter. Okay, so a centimeter is 0.01 meters, right? A centimeter is 1/100th of a meter. So we're going to say, okay, well, then I'm going to add this 0 on here to say that really this is 0.320. And so 1 centimeter above that, or 0.01 meters above that, would be 3.21. And this end would be 3.19. Okay, and so the middle of these two, here and here, boom and boom, are going to be like halfway between 3.19 and 3.20. So if you struggle to figure out what those are, I want you to think about adding another 0, another place back here, to allow you to think about these numbers as like hundreds, right? So if I'm looking at 190 and 200, well then this is 195, right? So if I think of this as 3.1195. I don't have all my normal tools here. And then over here I have 3.205. Okay, and so this is asking about the upper bound. So it's going to be this number right here. That would be our upper boundary. So again, making sure that we know how to use our decimals to really work these questions thoughtfully. Let's do one more. This one is kind of challenging. That's why I want to look at this one. So my bike is 1.5 meters long to the nearest 10 centimeters, right? So maybe it's not exactly, it's close. And the shed is 2 meters long to the nearest centimeter. or to the nearest meter, right? So will my bike fit in the shed? We're gonna say, is it guaranteed that it's gonna fit in the shed? So this question's a little confusing in that way. So let's make a little model for the bike. So the bike is gonna be 1.5 and the nearest 10 centimeters. 10 centimeters is gonna be 0.1 meters, right? 0.1 meters. So we're gonna add 0.1 meters, 1.6 and 1.4. It's the other way this could have gone. And we need these marks that are splitting the difference, right? So again, if this is confusing, I can think of this as 40, 50, and 60. And that's gonna allow me to sort of determine the values that are halfway between. So 1.45, 1.45, and 1.55. Okay, let's do the same thing for our shed. So here's our shed. And here's the line, again, not super pretty, to the nearest meter. So we have 2, 3, and 1. And our shed is going to be somewhere in this range, right? 1.5 and then 2.5. Then we have to ask ourselves, is it guaranteed this bike is going to fit in the shed? So what's the worst possible scenario for us? The worst possible scenario is big bike, tiny shed, right? So big bike, that's going to be down here on this end. Big bike, tiny shed. So is it possible that it won't fit? Well, 1.55 is actually longer than 1.5. So it's not guaranteed, right? So this question, we cannot guarantee that this is going to fit. That's why we're going with a no on this one. If you want to press yourself a little further, think about question 8, question 7. Those are going to be more challenging questions. This is 3 kilometers, 1 sig fig. So 1 sig fig would be going up to 1 or going down to 1 or up to, pardon me, going down 1 sig fig to 2 or up 1 sig fig to 4. And then we would be splitting the difference between those. This one right here, the lower boundary of my speed, we have same kind of deal as we did here with the bike where we have 2 situations we have to deal with. So think about those 2 questions. Those are definitely more of like the 6-7 level question. So you want to make sure you understand those upper ends if you really want to try for that higher score on this test. Okay, I'm going to clear this out. And if you have any questions about upper bounds, please email me. My Zoom is not working.